Okay, guys, welcome back. Today, hopefully you have the opportunity to review the programs that we start doing in the previous lecture. Hopefully you have the C compiler running in your computer, or at least you have the opportunity to connect to the internet and use one of these online compilers. My recommendation in general, not only for C, but for all the languages, if you can at least copy paste the code from the slides, type the code from the slides, in some cases they are pictures, and sorry, compile and run, just to be sure that it is clear what is happening there. That could be a good practice. Source code from the slides, sometimes go to questions to your quizzes or questions in your midterm. It is common that the TA help me copy paste code and modify some things, and that make a question. So play with those source code. Now, moving forward, we review the basics of a programming in C. At this point, you should be able to do at least the hello world, a program in C that prints hello world on the screen. You should be able to do something like mathematical expressions, use the operators, even maybe conditions or loops. I mentioned this in the previous class, conditions, loops. Some of the data types are the same that you know in Java. I only forget to mention one slide, the last one. And sorry, I think I want to mention this before we start. The only thing that is different from the conditions in C and Java, and it's going to be the same with C++, is one rule, one semantical rule. In Java, inside of the parentheses, what should you have there?
Boolean expression.
Correct. You need to have there at the end a Boolean value. A Boolean value could be something like 5 greater than x. It's a relational operator that is going to return true, false, a Boolean value. So you can have an if with something like this. But also you can have an if with something like true is correct, even though it's always going to be true, but whatever. You can have something like not is a Boolean value, and I can continue, right? You have these operators and or, you can use them, but at the end, it's a Boolean value. Something that we mentioned before in an example, but now you can try, is for the if condition in C++, what you have here, semantically correct, is an integer number. There is no Boolean values in C. We're going to review that data types today, but just finishing the example that we reviewed in the previous lecture, there is no Boolean in C. Instead of Boolean, the conditions are integer values. Integer values. The situation is 0 is considered false, and any other number is true. If 2 plus 2, question in your exam, this sentence in C++, correct or not? And it's like lexically correct, syntactically correct, semantically in Java could be wrong, but in C now it's correct. Why is correct? Because 2 plus 2 is an integer and the conditions are integers. So that is fine. What is going to be the meaning? Well, 2 plus 2 is 4. Is 0? No, it's not 0. That is true. Any number, true. 0, false. That one. If you have an else, you're going to be running the else. 2 minus 2, 0, false. That is maybe the biggest change in terms of the semantic in Java versus C and C++. Conditions, numbers. Anyway, we are talking about data types. Let's review in general the data types that we are going to have for working with C and C++. The data types in C and C++, well, in C first, these are your data types. Those are the only data types that you have in C. In C++, they add one more, Boolean. But it's not going to be Boolean, it's going to be bool. Like int. I am going to talk about the strings later. That is going to be one of the main topics for today. The main thing that you notice here is we do not have strings. Well, in fact, I am talking about the primitive data. In Java, you do not have a string as a primitive. You use the object string from the beginning, but it's not a primitive. So which language have more data types, Java or C? Okay, hopefully we agree. Even if we think about C or C and C++ together, I mean, if we review all the data types, there are several things missing here. I only have one data type for integers. In Java, short, long, byte, there are 3 more missing here. Floaty double, always together, the char, the void, those are also from Java. But what I am missing, the most important thing is here, something is happening. And obviously the Boolean is missing in C, but well, in C++ they put this bool. Remember, not the same name. Something is happening here. Well, something that do not exist in Java, but is going to exist in C and C++ are type modifiers. And the type modifiers in C are this. What is a type modifier? Well, you can ask the computer for an integer variable, but you can add here, like another word, a modifier for the type. For instance, you can ask for a long int, or you can ask for a short int, or you can ask for a signed int, and so on. The modifiers, just like public, private, and protected, remember those words that you put before classes or before methods? Now, we have this data type only, but we have these modifiers, and basically we can combine them together. And when we put together modifier and type, we're going to get something that is the one that is going to define the size and the format for my variables. So, help me, do you remember the difference between an integer and a long, or a short, or a byte in Java? size of a byte in Java? The memory, yes. Byte is one short.
I think 2.
2. Int.
4.
Long.
8.
Thank you. Do you agree with me? Those are the types in Java for integers, and those are the sizes. Okay, makes sense. If I want to put something like that in C, I will do the following. Int. And you remember that all the others are also int? I mean, something that someone told you is a long is an int, but bigger. A short is an int, but smaller. And we use 3 different names. In C, we're going to use int, 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 always, because that is the type, int, and we are going to use modifiers. I want a long int, or I want a short int. Instead of 3 names, I'm going to have 1 name and the opportunity to play with modifications. Now, it's not only about the size. It's going to be also about do you remember? What if I need an integer and that integer is going to store the grade of a student? The grade is never going to be negative. So I do not really need positive or negative. Maybe what I need is an unsigned integer. An integer that only, a variable for integers that is only going to have positive values, 0 and positive values. If I need negative, I can ask for a signed version of the integer. Why? Because remember, you have your integer, they are binary numbers, but when you use the sign, one of these bytes is going to be used to store a 0 or a 1 that represent the sign. So instead of having 32 bits for a group of 8, you're going to have only 31 using the last one for the sign. But if you decide that you do not want the sign, you can use the 32 only for values. So instead of having half and half, positive and negatives, you can have all of them positive, more digits, more values, signed and unsigned, long or short for the integer. But you can apply exactly the same to other data types. Long float, long double, short double. Combinations. Let's see the results. I can do combinations, and the difference is going to be at the end how many data I can store. And this is the table. Let's see. Char in C. The char is able to store a byte, 8 bits. But the char, by default, you have signed. Therefore, if you have 8 numbers ones in binary, the equivalent to that in decimal is something like 255. But if you are going to use one of the bits for the sign, then you only have 127 positive and 127 negative. instead of 255 positive. So if you choose with sign or if you choose without sign, in both cases the size is the same, but in the case number one, negative and positive, 1 to 7 is the maximum and minimum number, or in the second case, you cannot store negatives, but you can store 0 to 255. This is signed and unsigned char. Now, the question could be, what happens if I only put char? What happens if I do not put any modifier signed or unsigned? There is going to be a default. If you don't tell me what you want, the computer is going to use a default. What do you think? What is the default for char?
Signed.
Signed or unsigned? Do you remember what is a char in C? Unsigned, why? Do you remember that basically what we do with the characters is they are numbers, but they correspond to some particular symbol, the character, in a table? In Java, that table was the Unicode thing. In C, the table that we use for the ANSI C is going to be the ASCII code. The ASCII code is basically the numbers 0 to 255, and we have 255 different characters, including numbers, letters, uppercase, lowercase, and some fancy symbols, including the happy face and the sad face. By default, if you do not tell me anything, if you just want a char, the computer is going to understand that what you want to store is a char, a character. And a character is a value 0 to 255. So if you want a character, you want to use this guy, 0 to 255. But you can ask the computer for a signed char. If you ask for a signed char, you still can store characters, but in the table, only from the 0 to the 1 to 7, only half of the table. But you can use the other half for negative numbers. The negative numbers do not have an equivalent as a character. Again, the table in the ASCII code is 0 to 255, but you're going to be able to work in that way. A signed char is a char, a variable that is going to use one of the bits for the sign. Let me give you an example. Probably this is more like computer architecture, but I am going to give you this example working with 4 bits. Just imagine that each of these boxes is a bit for a moment. And imagine that my characters are 4 bits instead of 8. I just do not want to draw everything. Which is the minimum number that you can store here? And which is the maximum? The minimum is 0, 0, 0, 0. Do you agree? And that is binary. And if I ask you what is the equivalent of that in decimal, that is 0. Now, what is the biggest number that you can store here in the same variable, in the same 4 bits? The biggest number. In binary, all in ones, right? I mean, think about it. If I give you 4 spaces in decimal, the small number is all in zeros, and the biggest number could be all with 9, because 9 is the highest digit, right? So the highest number with 4 spaces could be 9999. But we're working with binary, so the smallest is all in zeros and the highest all in ones. But then the question is going to be, well, okay, all in ones, and that number, binary, what is the equivalent in decimal? $15, right? Now, this happens if I use the 4 bits only for positive values, because here what I have is 0 to 15. I can store any number 0 to 15 just using 4 spaces. For instance, I can go and say, well, you know what, 1 0 1 0, and I can ask you which is this number from binary to decimal. 1 0 1 0, thank you. And you can agree with me that this number is between the minimum and maximum that I showed you before, right? The 5 is one number in that range, and it's because it's a combination in 4 spaces of zeros and ones. Now, this is unsigned. What happened in a different scenario with the same 4 spaces, but I tell you, you know what, guys? We're going to use the first space here for the sign. So if you put a 0 here, it's going to be one version. And if you put a 1 here, it's going to be a different version. So this one is going to be positive, no sign, and this one is going to be negative. I have no idea which is going to be the number, but because this one is negative. Okay, 0, positive, 1, negative, sign it. What is the consequence here? Well, originally I have 4 spaces, therefore I can represent numbers 0 to 15. But now, because I am using 1 space, sign it or unsign it for the sign, I only have 3 spaces. 3 spaces, which is the smallest number that I can represent in 3 spaces. Everything is 0. The smallest number is still 0, positive. What is the biggest number? 1 1 1, right? 1 1 1, 3 1. It's not 4 ones, but 3. What is the equivalent of this in decimal of 3 ones? Thank you. So I can represent, using a 0 at the beginning, I can represent the numbers from 0 to 7. 7 positive. Now, what is going to happen in the other scenario? Well, it's going to be the same, right? The biggest number in one case is going to be all in ones, 1 1 1. But because I have this one here, it's going to be -7. I am not using this for the number like I did before to make the 15. I am telling the computer, this is the sign. Okay, so this is the number. 7 negative is going to be 4 ones. 7 positive is going to be 0 and 3 ones. And I can represent all the numbers, -7, -6, -5, 0, creepy thing, and 1, 2, 3 until the 7. Sign it and unsign it. I can use the sign, but then half of the numbers, because 1 bit is for the sign. Unsign it. I can make biggest numbers because now I can use 1 bit additional for the numbers. And important, you notice what happened with only 1 bit additional. We go from 7 to 15. 1 bit, 1 additional bit. Move twice, almost, the capability, the sizes. So That is the reason, because going back here, I have the char. I give you the example with 4. You can play and make the translation of the bits and bytes in 8, and these are the numbers. With 8, you can create from the 0 to 255, and if you use 1 for the sign, you have 7 bits, and with 7 bits, you can play with 1 to 7 to 0 character. Makes sense? Yeah, that is the crazy part that I mentioned here, the 2 zeros. That is not going to happen. What is going to happen really, and this is something that you're going to review in the hardware part, but what you have is really in the computer, this -1 to 7, the 0, and the computer is going to move 1 to 8 positive. You're going to have one additional positive, and that one additional positive is the one that is replacing this idea of the -0. Hardware level, how to handle the values. So no -0 do not make sense. Moreover, the computer is going to help you, and you're going to have one more value, usually positive, but it depends on the computer. But there is always one more value here than here, because you're going to reuse that value that could be the positive and the -0 that do not make sense. Well, remember, always all the numbers in 1 is going to represent, like if you play with 8, bits, all in ones, this is the 255. And all of them with 0, this is the 0. So if you think about how many numbers you can represent, is all the numbers from 1 to 255 and the 0. So you have in total 256 combinations. That is the way that it works. So 256 combinations, but the highest number is 255. Remember what happened with the size of the array and the last index of the array? Because we're working with the 0, if you have an array of 10 elements, is from the 0 to the 9. So similar here. If I play only with 4, is 1 to 7, but because we have the 0 and well, all this handling of the positive and negative, you are working with 1 to 7 negatives plus the 0 plus the 1 to 8, a total of 256 combinations, and those 256 combinations include the 0 and some negatives, some positives. Good. So that is with chars. That is my explanation with 4 bits, and that is what happened here with 8. What happened with the short and long? If you ask for something like long char, or if you ask for something like short char, the computer is going to ignore you. Long and short do not apply for char. The only thing that you can do with chars is sign it, unsign it, or nothing. And if you put nothing, there is a default. And that default, 0 to 555. Chars. Integers. Did you notice what happened with the integers? You can use all of them. You can ask for sign it or unsign it. You can ask for short or long. And here, the situation is going to be different than the situation in Java. Number one, what happened with the integer? The integer by default. If you ask for an integer variable, well, you are not telling me if you wanted signed or unsigned. You are not telling me if you wanted short or long. By the way, you can put the modifiers in any order. There is no particular order. So can you guess, if you ask for an integer and you are not telling me long or short, what is going to be the default? Thank you. Yeah. By default, an integer, if you do not ask for a particular modifier, the computer is going to give you short. So if you ask for nothing, you get a short. If you want a long, you need to ask for long. Moreover, if you do not tell me if you want signed or unsigned, a character by default unsigned, an integer by default signed. Integers, positive or negatives. Now, quickly, a question in the chat. Very important question. Just imagine that I ask in my example, I am going to work with 4 bytes, but just imagine that in 4 bytes, I ask for a signed char x signed. And just imagine that I store in that variable the number 3 signed. Negative 3. What is going to happen in the memory? Negative 3 in a variable that is signed. The 1 here because the minus, and the 3 in binary is something like this. So I have the minus and I have the 3. Makes sense, right? Now I have another variable, unsigned. And in this unsigned variable, I am going to store is unsigned. I am going to store the 3. Anyway, well, let me change the 3 for an easy one. I am going to store a 2. Is unsigned, and I want the 2. That is a 2. But because I do not have sign, all the others are going to be zeros. Makes sense? Now, this is X and this is Y. What happens if I ask Y equal X? If you make Y equal X, well, can you agree with me that I am trying to store -3 in a variable that is unsigned? I am trying to store a negative number in a variable that is supposed to be only positive numbers, right? I mean, that is the idea. What is the computer going to do? The computer is going to copy this here. Makes sense, right? Copy the value that is inside to the variable. I usually use decimal numbers, but you need to remember that the computer works with binary. And working with binary, well, this is the result. Now, if this variable is unsigned, and this is the -3 signed, this y cannot be minus 3 in this variable because I asked for something where this is not the sign. What is the value that I have inside of y? You are going to have a program in C. When you run your program and suddenly you have a result that is like, do not make sense. I am copying this line and this line should be minus 3. But when I do a print f as a decimal value of the y, the computer is printing 11. My computer is not working correctly. Your computer is working correctly. The problem is the developer that do not understand that you cannot store a negative value in an unsigned variable. The computer is going to do it. It's going to become an 11. Clear. In Java, guys, Java is like programming with a nanny. In Java, everything that looks bad, the compiler tells you, programmer, something is wrong here. Something could fail. You have a virtual machine. If you do something wrong, the virtual machine is going to tell you, exception. You did something bad. Please fix. Java is very, very protective. Java keeps you safe. When you move and program with C, it's like you are free. No more nanny. No one is going to tell you that something is wrong. The number of compilation errors that you're going to get in C is nothing compared with Java. The computer is going to try to do everything that you ask. So if you ask for a unsigned to be stored in a signed or the opposite, both cases, the computer is going to say, okay, no problem. I can copy the binary number to the other place. The computer is going to be okay with anything that you ask. The problem is the results that you are going to get. Your program is going to report 11 and it's not the computer problem. Good news. This is the default in the language, but if you use a fancy IDE, whatever you're using, your fancy IDE is going to try to be your nanny, and your fancy IDE is going to try to avoid you to do things like this. But that is your fancy IDE, and the messages and how much the IDE do for you is going to depend of the IDE. Yes, you want to use a fancy one, but I need you to be aware of what happened when you do not have that fancy help. In the hardware, mostly if you go and work into an embedded something, this works and this is the result because this is the action in the hardware level. That's it. Well, continue with the types. In the types, something that is important. By default, integer, signed, integer, short. Now, the integer by default, the signed short integer. Two possibilities, depending on the computer. This is the first time that the size of a data type is going to depend on the computer. In Java, always, an integer is 32. It doesn't change. Portability, remember? Now, in C, C++, the size of an integer, 32 bits or 16 bits. To be honest, today, basically is 32 in any computer. Probably if you run the program online or in your computer, it's going to be 32. If you check, you're going to be able to do more than that with the integer. The language is for the 70s, 80s, 90s. In those moments, usually personal computer or a small computer, 16. But if you run a program or if you program with C in a supercomputer, that was 32. Today, your laptop is more powerful than the supercomputer of those times. So just to be sure, an integer, the size is depending on the platform. If we're working with computers, probably almost 99% sure it's going to be 32. But because you can program in C, several different devices, Arduinos and refrigerators and things like that crazy, the size could be, for some compilers in some platforms, still 16. So again, the size is not like in Java. You do not have this fixed 32 always. Here, it's depending on the platform. But well, if you go with 16 by default, when you ask for a long, the long is going to be 32. But obviously, if you have 32 by default and you ask for a long, the size is going to be 64. And well, when you ask for signed or unsigned, what is going to happen, similar with the characters, is you have one more bit. That means you can move from something like this instead of something like this. So instead of these 4, you have these 2 positive and negatives. You can count how many zeros, millions, billions, whatever. Twice if you only use positives, or half and half, more or less, if you decide to use positives and negatives. All the sizes that I give you here are assuming 16 bits for the integer. Therefore, 32 is the jump to the double. If you have 32 in your computer, the jump is 64 again. And you can make any combination that you want. Now, any combination that you want. Can I ask for a signed, short, I changed my mind, unsigned, int, x. Can I put that in my computer? And what is going to happen? This is the type. So everything that I put before the type is a modifier. You can use one or more modifiers. There is no particular order. There is no particular limitation. So theoretically, yes, you can put these 3 words. What is going to happen is signed and unsigned. The computer is going to ignore you. And for the computer, you are asking for a short X. Okay, but signed or unsigned, because I ignore what you ask, I am going to use the default. You are going to end with something like this. Yeah, that is the format. Makes sense. If you write something crazy, the computer ignores you. Unless you have a fancy IDE, the computer is not going to tell you errors or something. It's just like, whatever, programmer is wrong. And it's going to apply the defaults. And the same could happen with Char if you try to create something long, short, whatever. They didn't cancel like that. It's just because they are opposite. The compiler is going to read both, and basically the compiler is going to take the decision to apply the default. It's like there is always this default thing, and instead of telling you an error, the computer applies the default. I do not understand something, apply the default. That is more or less the way that the compiler for C is going to work, applying defaults. So it's a good idea to know the defaults, and every single time that we notice that a default is being applied, is probably because something is wrong in our programs. Exactly. If you put all the modifiers and int, so unsigned, signed, char, long, int, the computer is going to say, see, whatever. You are asking for an int, and therefore I apply the two defaults for char, long, signed, unsigned. Is ignoring you and applying the defaults. Yep. Any combination that you can think about it. If you put something crazy, no error, use the computer ignores you and apply the defaults, which is the opposite to Java. In Java, probably the compiler could tell you wrong, 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 fix it, fix it, fix it. And until you write something that makes sense, then the compiler continue. Here is just like, I ignore you, apply the defaults. Well, float and double. For float, no modifiers. There is no short or long float, and you cannot have signed or unsigned float. Not possible. So the only default that I can mention here is obviously floating point numbers, always, always, always sign it. You always have a sign in the floating point numbers. You cannot express or represent floating point number without a sign. So you can ask for signed, unsigned float, and the computer ignore you. And the same idea with long and short. There is no long or short floating point number. For float, it's just float, flat. And 32 bits, the same that in Java, the same size as an integer most of the time. And the precision of a floating point number, similar to Java, 6 digits after the dot. So you have a precision of 6. That is very, very similar to the Java virtual machine. Now, with the double, usually the same rule apply. You only have double. You do not have unsigned doubles. That is not possible. Doubles, just like float, have always a sign. One possibility, you can ask for long double. And you can ask for a long double, and the long double could be option number 1, I ignore you. Ignore you because I cannot create the long unless you have access to a good computer, a supercomputer, a computer with a little bit more power than a normal trivial PC. You can do it. You can ask for a long double. In most computer, it's going to be ignored. In most computer, your doubles and your long doubles are going to be used the same. Probably more than 50% of your computers, or my computer. But if you work in another kind of computer, if you connect to one of the ASU servers in the high performance computing thing, you get access to program with C, and you can create a long double. And you have a number with 128 bits, and you can calculate the value. But the most important thing is this big number, and usually the doubles are going to keep this precision, usually at least 10, but you can get to 15 precision digits in any computer, even in your PC. The only thing is the long double is not going to increase the precision, it's going to increase the size of the number of the real part, the size, how many digits you can handle there. So float, no changes. Double, I will tell you, usually no modifiers for double, unless particular cases with good computers, long double is valid. And please remember, in C, there is no Boolean values. Boolean values are going to be added in C++. Why I am mentioning this guy here? Because usually, if you are using a fancy compiler, for instance, if you are working with Visual Studio, if you read the small letters Visual Studio is a C++ compiler. When you notice this, C++ is because the compiler works with both languages. Obviously, if you do here your homework and you ask for a bool, it's going to work. Not because it's C, but because the compiler is working with C and C++ together. So, bool is from C++, not for C. My compiler is, I select a project in C and it's working the bool because your compiler is working C, C++ together. You create a project for C++ or you create a project for C and apply the grammar of both languages. So allow you to have your bool. But this one do not exist yet. 70s, C, no bool. 80s, C++, they are going to add the bool. Good? These are all the data types that we have, all the primitive data for C. Now, do we understand this program? Particularly, what do you think about the 14th line? What is that? A variable, integer, with the name y and square brackets. Good news. The square brackets, they represent arrays, not only Java, but also in C++. 14 is an array with 3 elements. Do you remember if that one is the same in Java or something is missing compared with Java? Every single time in Java that you want an array, you need to use a particular keyword, remember? Yes, the new. Good news, in C, we do not need the new to create an array. That is an array, period. That is the only thing that I need to create an array. That one, the line 14, is an array. Y with, as you mentioned, 3 elements. Each element is an integer. That's it. If you compare Java with C, small. Go to the point. What is that? Your array. Do I need a new? Not yet. We're going to use the new. Don't worry. The new is coming. But that one works without the new. The new, or whatever equivalent we're going to review, is not mandatory in C like it was with Java. So line 14 is an array. Line 13 is use a variable. They are integers, right? And I have the main. Do you remember? The main can return an integer. Do you remember the main without parameters? And do you remember the include? What is include? The equivalent to import. This library, why I need that library? stdio. What is inside of that library? These 2 instructions that I need to put, thank you, to put something input output, in this case output, to print something on the screen. Are you going to use printf? Do you remember this percentage? What does it mean that I am using that percentage there? I am going to print a variable, right? What is this \n? The enter, just like in Java. A new instruction for you guys. Size of is an instruction. The instruction go before the name of a variable. Size of. What do you think is going to do size of if you are giving a name of a variable? It's going to give you the size of the variable. size of, and then you put X and Y. The output of this program is this. Size of X for what?
Bytes.
For bytes, 32 bits. The computer in which I run this program is able to give me 32 bits, 4 bytes for my integer. Why the second one? Y is 12. It's an array of 3 watt integers, 3 times 4. So we have data types. We do not know the sizes. Well, we have an idea of the sizes, but we mentioned that in sometimes the size depends on the platform, the computer that is running the program. Well, something that is important to have is an instruction that we can use to check the size of something. So I can create a variable. I can create a variable X, and then I can ask for the size of the variable X. And because I know that it's an integer, well, I can check if the size of the integer is 4 bytes or more or less, 2, 4, 8. Check my computer. A PC computer is going to be 2, it's going to be 4. Maybe in a different platform, you can get 8. I don't know. Well, the sizes by default, you'll be careful with these ones, but you can use size of with any variable. You create the variable, ask for the size, and you can print on the screen the size in bytes for that variable. So you can check if your computer is able to give you the spaces that I am mentioning here. My table is correct, hopefully yes. Practice with this could be a good idea. Now, next. Those two are correct. What do you need to do? Unsigned in, unsigned, int, can I store this number in that variable? Yes or no? Question in your exam. How do you know? Oh, because it's unsigned, go from 0 to this number, and this number, this one is lower than the top. So good. The second one, use an int. Is correct to do this? Yes or no? You need to think about, okay, which is the default if you are not giving me anything? Is signed or is unsigned? Oh, is signed. Okay, what is the default with long and short? Short. Okay, that one is a signed short. Okay, if that one is signed and short, those are the values. Signed, the short is the same as int, whatever. Minimum minus 32 something to 32 something. Oh, good. This one. Correct or not? Hopefully, yes. Int x equal 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct or not? Nine digits in an integer. Is it going to work? Okay. Good. So you know about it. Data types. What about this program? if I give you this, can you explain me what is happening? Moreover, can you explain me why this is the output? Like, can I do that if age, and age is a variable char? Moreover, in the variable char, I store a 90. Error? Hopefully you agree with me, it's fine. Chars are numbers. You can store the 90 because the char is able to store 0 to 255. 90 is fine. If age, the only possibility to be false is if age is 0, but any other number, as we mentioned before, is true. So if age is 90, that condition is true. And if that condition is true, you are going to execute the line inside of the if, which basically is going to print, by the way, it's going to print as a decimal with an enter, the value of the variable age. And that is the reason because I am printing here the 90. This else was not executed. Here, I am changing the value of the variable to 0. And the only reason because I changed that to 0 is because now I have again this if, and now this variable is going to be 0, and 0 is false. And because it's false, well, this is not going to be executed, but we're going to execute this one, which basically is printing the last line. No Boolean, integer values, chars, the char type, store numbers, integer values. By the way, question for your exam. What is the equivalent of the type byte in Java, but in C? Equivalent of byte from Java to C. Yes. Question in your exam, the equivalent of byte in Java, the data type byte in C is the data type char. Why? Byte, 1 byte. Char, 1 byte. Byte is for storing numbers. Char is for storing numbers too. That is the equivalent there. Now, regarding the percentage, remember always that you want to use printf to print the value of a variable. Something that you need to do is, number one, you need the name of the variable, whatever is the name of the variable. But before the name of the variable, always you need a string. And that string need to tell the computer what is the type of the variable, what is the format in the variable. And the way that you do that is with a percentage something here. The something that you can put there is D for decimals. That variable is a number, a decimal number. Decimal, I am talking about base 10, not about the decimal dot. The variable is an integer in a decimal format. You can use C to print in a char, a character. You can use the S to print a string. We need to talk about strings. You can use the P if you're going to print a pointer, the address of a variable. That basically means that you want to use the hexadecimal numbers, not the decimal ones. And you can use F if you want to print something in floating point. Floating point, the decimal point. It could be float or double, doesn't matter the type, but you are asking for printing something that have an integer part, a dot, and a decimal part. So these are the letters that you can use here with the percentage, and you need to indicate that every single time that you want to print something that is a variable. Obviously, if you want to print hello world, the only thing that you need to put is hello world inside of the quotation marks. You do not need to use all this stuff. This stuff is when you need to print a variable because you need to specify what information that variable has. Summary of the previous lecture, right? You can go back and watch the video with all the examples, but this is the big picture of why the percentage. Hopefully help. Okay, this is clear. My recommendation again, copy paste and be sure that this is true. At least it's true also in your computer as was in mine. Arrays, next step. I show you one example. We start with arrays in a very easy way here. We need to talk more about that. It's like we need to show the details of the arrays. The details. Do we understand this? Those are instructions in C++, but hopefully with your knowledge of Java, you know what is happening there. Line number 1. What is happening? I am doing a declaration of some variables, right? Which variables? How many variables? Can you agree with me that in the first line, what you have is a variable I that is an integer, a variable j that is an integer, a variable key that is an integer, and you have an array A, and that array A have 3 elements, and the key idea that is an array is that the 3 elements are consecutive in the memory, and well, is the 0, the 1, and the 2, use the index that we use. So this first line is giving you this. What is the value in the variable j if I print it? What happened if here I do a print f %d and I print k, use there. Garbage. I really hope that you have the opportunity to play with that. If not, try to copy this line in a main and then just print your variable. Again, if you're working with a fancy IDE, your fancy IDE maybe show you a yellow light or a yellow sign telling you you are trying to print a variable that do not have initial value. That could be something fancy, but if you're working with use any compiler that is not taking care of you, you're going to be able to print garbage. Garbage for this one, this one, this one. And the most important thing is, which are the values inside of every single position in the array? Also garbage. Important, guys. In Java, all your variables, zeros. Your array with the 3 elements, zeros. Here, see, all of them, arrays or not arrays, they have garbage. Next line. What is this? MA is an array, right? A 2D array. So help me, 2 and 3. How many columns and how many rows? 3 rows or 3 columns? 2 rows or 2 columns? Very important, guys. Usually in math, you work with this idea of X and Y. For the arrays, is not like that. For the arrays, the first number, always, 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 the 2D arrays are going to be the columns, which is Y, not X. So just remember, arrays is not X and Y, it's not geometry. So in this case, 2, 3, 2 rows, 3 columns, correct. That is the reason. And do you remember that you can initialize an array giving values to the array, use like equal, curly brackets, and put the values inside, and this work with 1-dimensional arrays, 2-dimensional arrays, 3-dimensional arrays, or whatever. You can put values inside of an array doing this. And if you do not remember, I am telling you, this is from Java, and the same thing works in C and C++. This is nothing new yet. Line 1, line 2, similar ideas, that things that you can do in Java. Only one thing changed. I do not need the new here. I do not need, well, obviously if I am doing the initialization, I do not need the new, but here in particular, I do not need the new. So far, the data types, the size of the data types, and at least this initial idea of the conditions and this initial idea of the arrays. Any questions so far? No? Yes, no, maybe? Okay, no, perfect. Okay, guys, I am going to stop here, and the next lecture, I am going to continue with all the slides that correspond to arrays. We're going to use some time with arrays, and then we move forward. Good? So see you next time. Thank you.